Hi, I'm Geoff Vallis. I'm a Professor of Mathematics at the University of Exeter, and I'm here to talk to you a little bit about the department, but mainly about the kind of work that I do in the department. Our department at the University of Exeter has both pure mathematicians and people who study the applications of mathematics, and I'm one of the people who uses mathematics to study other things. In particular, I study climate. Not all of our people do that. Some of them are very pure mathematicians and they look at things like the properties of numbers. We can have even numbers, odd numbers, and prime numbers. Prime numbers are numbers which can't be divided by any other number, such as 7 and 11. And we ask questions like, is there an infinite number of prime numbers, or is there a largest prime number? And can all the even numbers be expressed as a sum of two prime numbers? For example, we can express the number 10 as the sum of 7 and 3. These questions are unanswered, and if you can answer them, then you'll become very famous. But the things that I do are looking at the applications of mathematics into climate. Climate is another major problem facing the world. It's not an immediate problem like COVID, but it's certainly a problem that we'll be facing over the years and decades ahead. And I'm interested in the problem of global warming. Global warming is what has been happening to the planet over the past 100 years. We've seen about a 1 degree rise in temperature over the past 100 years. And we expect to see at least another degree and perhaps more over the next 100 years. And what's causing that? Well, what is causing that is that we are putting greenhouse gases into the atmosphere, like carbon dioxide. And we're doing that by burning fuels like petroleum and coal. And so the amount of fossil fuels or greenhouse gases is almost doubling in the atmosphere, or is expected to double in the atmosphere over the years ahead. These gases trap the radiation which the ground is emitting and so keep us warmer. It's just like putting another blanket on the bed to keep you warmer. So we know that is happening. What we don't know is how fast it will happen and whether there'll be some sudden changes which could be catastrophic to society. And I'm particularly interested in things called feedbacks. So feedbacks are when something happens which causes something else to happen, which then amplifies the initial effect. So let me illustrate that with just a little experiment here. See, here's a plastic bottle full of milk, and I can hold it, and it's kind of more or less stable in the middle. But if I tilt it slightly, all of the milk goes down to one end and it becomes unbalanced, and then it suddenly tips over like that. Let's see that again. I tilt it slightly, and then all of a sudden it takes off. So that's illustrating two important effects which we think are happening in the climate system, or which might happen in the climate system. One is the feedback, that as I tilt it slightly, the liquid falls to one side of the bottle and that causes it to tilt more, and that's a feedback. And then somewhat more catastrophically, as it all goes to one end of the bottle, it reaches a point of no return and it can't come back. There, it's gone. And that's called a tipping point. We're very concerned about whether tipping points can happen in the climate system. For example, as the planet gets warmer, all the ice in Greenland starts to melt, raising the sea level. If a tipping point happens, then there'd be no return for that ice in Greenland, and it would all melt and flood the seas, and the sea level would rise by, well, about 7 meters. And clearly that would be catastrophic to many cities of the world. The other kind of feedback which we're afraid of, if you will, is called a runaway greenhouse. Now, what happens in a runaway greenhouse? As the climate gets warmer, the atmosphere can hold more water vapour, becomes more humid. Now, water vapour is another strong greenhouse effect, just like carbon dioxide. So as we put carbon dioxide into the atmosphere by burning fossil fuels, the atmosphere gets wetter. This also traps more radiation, so it gets warmer and wetter still. And you can imagine that the whole thing can feed on itself and become catastrophic and go into what is known as a runaway greenhouse effect. Those runaway greenhouse effects, that we believe it actually did happen on Venus about 1 billion years ago. We think that Venus once upon a time had an ocean, but the ocean boiled, put more water vapor into Venus's atmosphere, it got hotter and hotter, and eventually all the water disappeared. Well, we actually don't think that will happen on Earth, fortunately, but we are kind of afraid that it is possible that some of these effects, which we can't predict exactly, might happen, and we might get sudden increases in warming. Well, of course, we don't know any of these things at all for certain, and that's why we study them. And we try and make mathematical models of them, using all kinds of models, sometimes pen and pencil models, sometimes computer models. We use supercomputers, and sometimes we even use mechanical models like the model of the bottle that I showed you. Well, that's what I do, and it's what people in my group do, and I have undergraduates working on similar kinds of problems. And if you do decide to come to Exeter and study mathematics here, you'll be exposed to both a range of problems in both pure mathematics and applied mathematics, and you'll get the opportunity to work on some of these really important problems as an undergraduate. So I hope you will give Exeter every consideration, and I hope that you are surviving well and able to work well in these rather trying circumstances, and let's hope it all gets back to normal as soon as possible. And I hope to see you all at Exeter in the autumn.